pancake operator joke.
We can automate anything, including the pancakes.
Complex pancake.
Yes.
All right, hey, Alex Williams, the new stack here in Copenhagen at KubeCon Plus Cloud Native Con with the new Red Hat team, but people who I've known in this world for quite some time, going way back into, gosh, several years ago. So your careers have been on parallel kind of roads in many ways. You've run into each other at events and everything else, and now look at you. CoreOS has been acquired by Red Hat. What's it like now to kind of like intersect at Red Hat after all your paths and journeys through this crazy time that we've been through over the past 3 years?
Yeah, sure. So it's kind of like two very close families coming together. Red Hat and CoreOS in the Kubernetes community have been pretty closely aligned on some of our views on where to take Kubernetes ecosystem, where to take the Docker ecosystem, and so it's been pretty good last few months bringing the teams together.
Yeah,
So.
I think we had you on an OpenShift Commons gathering upstream this panel maybe two years ago or so. The thing about the Kubernetes communities is all the cross-community collaboration that happens, and it's always been a pleasure working with the folks from CoreOS and on different projects. The collaboration really, we set aside a lot of any sort of corporate masters work because we're just trying to get this thing done, and the different projects that are under CNCF, it's almost like we were already working together, but not.
Yep. Yeah.
That drives value in so many different ways, doesn't it? Because it forces you to really apply principles that you've learned and through your own development experience and through your own operations experience, doesn't it?
I think the processes that were put in place around the CNCF and around the Kubernetes SIGs and things like that really helped enable the growth of the Kubernetes community and the separate projects that are under CNCF.
Yeah, I think also like we just have naturally CoreOS attracted a bunch of engineers that cared deeply about open source, and then Red Hat obviously has some history there in doing open source work. So
yeah.
So I'd like to talk about what you guys are thinking about in terms of operators, but and then Libby's been looking into this quite a bit. She saw your keynote this morning, so I want to have her ask some of those questions. But I'm curious on, we've kind of gone through this adoption rate of Kubernetes, and the community depth is showing remarkably here.
Yeah.
At this event where we're 4,500 people, it still seems like a very much of a community-oriented event, right? And that, in just upon reflection, seems to have driven a lot of the innovation too, because you're always looking for those optimizations. You're always looking for those efficiencies to kind of, to drive it forward. But I'm curious, are operators the manifestation of that? Is it through that through that process that you found yourself looking for operators? Because I think that's one of the things I think is unique about these communities is they do grow organically like that.
Yeah, I think the motivation for operators when we started thinking about where to take Kubernetes next was really, what are the things that the cloud providers are doing where open source and small software vendors don't have an opportunity to compete? And I think what we've seen in the public clouds is essentially the two pieces of software. There's the hosting bit, which has always been a business for a long time, and then there's kind of this software delivery piece. And for a while now, open source software outside of the single server hasn't had a way of delivering its value across clustered and multi-server environments. Besides, like, here's a bunch of docs and good luck. And I think with operators, really what we were trying to do at CoreOS and the vision that we are continuing to execute on at Red Hat is how do we make it possible for people to, across their data centers, across cloud, bring software, whether it's open source or non-open source, but bring that sort of cloudiness to all those different environments without duplicating the work every time they have to move where those servers are being hosted. And that's kind of where we've taken it. And This is an extension. It's like a continuation of what Kubernetes is doing for people today. What Kubernetes is doing for people today is simplifying compute, network, and storage, and ability to consume it. And so we're like, well, how do we simplify applications that are consuming compute, network, and storage? It's just moving up the stack. So.
Libby, we were talking a bit about kind of the role of the operator, and I would love to just kind of hear like what is the vision of the operator, but I know you probably have some specific questions as well.
Well, I'm just curious really how it all works, because it's one thing that I'm having a difficult time understanding is like why you need a separate runtime for an application, a Kubernetes application. So can you explain a little bit just what an operator is? Yeah,
for sure. So the idea here is that out of the box, Kubernetes gives you this abstraction of a pod and a deployment and a service, and these are kind of just fundamental compute things. Essentially allows you to run a piece of software and then give it network connectivity. So those are fundamental basic building blocks. But what we find people doing, and like why the public clouds have taken off so much for developers, is they are able to not just say, I need a VM, but they're able to say, I need a database, or I need a load balancer. And so what the operator is doing is it's adding new nouns to that basic language of compute, network, and storage. Now we're able to say compute, network, and storage, but also load balancer, and also database, and also, like Aparna did on stage, also a Spark queue. And so those abstractions are like what make developers so effective when they're running their application on cloud, is they're able to take these off-the-shelf abstractions and say, just give me another one of those. And they're as free as they are with VMs. Like 10 years ago, everyone said, oh, VMs are great because I'm able to spin up a machine and then tear it down, and it's like practically free. Well, these applications have not been practically free until cloud. It was kind of a chore to like spin up a Postgres database, and then Amazon really simplified that with RDS. Well, there's no reason with Kubernetes, and actually Kubernetes has distinct advantages because you can extend it at runtime, that Kubernetes can't give that same developer experience of, I need a database, oh, now I have a database.
So you're expecting each individual database application to create its own operator.
Exactly.
Yeah.
So
to run on Kubernetes as the control plane.
And available as a resource?
What now?
And that makes it available as a resource?
It makes it available as, so once you've built an operator, the idea is I can say, let's say there's a Postgres operator. I can say, give me a new Postgres database. I have a new Postgres database. Destroy that Postgres database. Destroy it. I need 3 Postgres databases. I have 3 separate Postgres databases, which makes it possible for teams to really simply have CI/CD, really simply spin up a reproduction environment for production. Let's say that they've encountered a bug and they want to reproduce it. Because they have that noun, they don't have to think about just raw Postgres. They can just say, give me a Postgres database, and one appears. And it's kind of the superpower of cloud and why you see this rapid adoption. I mean, the quote that I had on stage about Ticketmaster, you're not going to have application developers spinning up monitoring systems on their own. Like, that is not what excites them day to day. But you give them the ability to make a single API call and get a monitoring service. Now you have hundreds of them, and they're able to more effectively monitor their systems. I forget the term, but there's this idea back in the 1800s. Coal started taking off, and then the price of coal went down, and they saw a huge increase in the amount of coal being consumed. And essentially there's this economic theory that anytime something is more readily available, consumption will go up. And so what we want to do is with Kubernetes, like if you make these high-level APIs more readily available, consumption of Kubernetes will go up. Kubernetes will win. You'll have more nouns, more databases, more load balancers, whatever, ending up inside of Kubernetes. So we really want to see that flywheel start to appear.
And so some of the key of that is having the operator framework as an SDK, and helping people develop new operators as well. That's one of the goals here, is to get the word out, get the SDK into people's hands, and can develop a whole slew of these operators and new nouns for these frameworks.
Yeah, and we're starting to see it. We have, before the operator framework and the SDK, there's probably about 20 of these that they exist. But I want to be able to see, like, a year from now, 100 or 200 of these things exist. And I think it's at the right time. We have every major cloud vendor in the room. We have every major enterprise software vendor in the room. And so the market of Kubernetes is starting to work. And I think we can take that market momentum and start to bring all the various software vendors and open source projects on board as well.
Really interesting. Can you explain the other aspects of the operator too? Because there's a lifecycle management component, and then there's the third one as well.
Yeah. So we introduced two components in the operator framework. The first component was an SDK, which is designed to simplify development. The analogy that Philip Whitrock from Google used. Developing web apps 8 years ago was really difficult, and then this thing called Ruby on Rails came out, which made it really easy for you to generate the scaffolding and get a web server going. And so he's been talking about this whole idea of a SDK as a Kubi on Rails.
Kubi-doo.
Oh no.
for Kubernetes. And so the SDK is doing something similar, trying to simplify the generation of these operators and native apps. And then the other piece is lifecycle management. To go to Michael Goodness at Ticketmaster, who has deployed all these copies of Prometheus, this monitoring stack in his cluster using the Prometheus operator, he now has hundreds of these things to manage. And so he needs to make sure that the teams aren't running out of date versions, that he has an inventory of all those things, that teams that aren't supposed to be deploying monitoring, maybe he's banned certain teams from deploying monitoring systems, aren't deploying monitoring systems on top of the clusters that he maintains. So all this kind of life cycle around who has access, what instances exist, where is it installed, what versions is what we're trying to fix with lifecycle management. And it's not just operators. There's a bunch of components inside of Kubernetes that have this kind of lifecycle piece. So we're pretty excited to open source this lifecycle manager too.
The thing I keep thinking about is like API haywire, and I think about all the different kinds of proxies we've seen developed, and now we're starting to see service mesh involved. How will the operator work as, in managing all, those various APIs that people will have access to?
Yeah, I mean, the nice thing is, like, this is all being built on top of Kubernetes services and service discovery and all that stuff. It's really a
communication network, isn't it? It's a communication layer in many respects.
And the neat thing about operators is that we're taking advantage of just the fundamentals of Kubernetes. So to go to like our Postgres example, we ask for a Postgres resource, but then at the end of it, we get out a Kubernetes service and a Kubernetes secret. And everything inside of Kubernetes knows how to deal with those things. Whether it might be a monitoring system or a service mesh or whatever, it knows how to interact with those. And so our hope, and I think the opportunity with Kubernetes, is that we start to actually become a better cloud than the clouds are at delivering these services. And I think that's a big.
There's something to say for that.
Yeah.
Well, there's something to say with that in terms of also being able to deliver a hybrid cloud as well, so that you're not dependent on any one host, which is really one of the other goals of Kubernetes, is that you can run it anywhere.
For sure. Yeah, I mean, imagine making a conformance suite for an application and not just being it's able to run a container, but it's conformant and it is utilizing this Postgres database and this Redis cache and this load balancer, and all those components are conformant as well. You're able to shift this whole application stack, like you're saying, from running on my laptop, which you can't have a public cloud on your laptop. You're programming on a plane, you have this full stack, and you shift it over to a public cloud.
You could have cloud in a box, right?
Sure.
I thought that was a thing, man.
Try to get that on the plane.
So listening to your keynote this morning when you were talking about the operators, what really struck me about this was just how this really fits in with the values of the Kubernetes project itself. That ability to shift and lift, right?
Yep.
And so I think, and also when it comes to CoreOS and Red Hat together, like that to me seems like one of the core.
And always in the open. So I think that's one of the wonderful things about CoreOS is that their open source ethos and CoreOS and Red Hat are really pretty wonderful. And this project, again, is all out in the open, and that's part of what's happening here at KubeCon and CNCF. We're really trying to make sure that this is a big collaborative effort.
You're giving the tools to the application developers themselves to make this happen, to make their applications work.
So who manages the operator? Who manages it overall? Because that's where you start to get in, because it's going to need to be optimized at certain points, right?
Yeah, so the manager, the way we see it is that the person, the cluster operations person, is whoever that is, he or she is in charge of inserting those things and making them available to the application developers. Similar to like on a public cloud, a person who is the kind of cloud manager, they're able to say like what APIs you're able to talk to, and so that's where we see the management happening is, hey, we're making this service available to you, you're able to consume it, but we ultimately have control over the versions that are running, and we can take that away if things end up being a problem, and that's kind of been a common pattern in cloud, and I think it'll be a common pattern in Kubernetes, is this split between the people who maintain the cluster and what versions are available of certain services, and then the folks who are the application developers who are focused on the application, and they're experts in the application and the business logic, not necessarily the infrastructure. Mm-hmm. Yeah.
So again, I guess the question that I have is about the actual kind of authority that the controller that the operator provides to the to the one who's building it. Is this then more of like a role than that you would see in SRE play? I mean, what kind of expertise do you need on your team to be able to do something like this?
Yeah, so there's really two personas that we're talking about. The first persona is somebody who's consuming the operator SDK. That person doesn't really need to know as much as they. Yeah, that person needs to essentially be an expert in the application that's being managed.
Right.
And then enough of a familiarity with software engineering to like build something that can take their operational knowledge, the stuff that they're maybe having shell scripts or they're doing manually, and encode that into an operator. The consumption side is really, really easy if you're a user.
Yeah, right.
You make an API call with kubectl and you get your thing, or you see the statuses. So they are these operators are sophisticated pieces of software. Once you get to a certain level of advancement, we do also in the operator framework, I didn't really talk about this, but if you just have a Helm chart and all you care about is installing the app, we have a thing that will adapt your Helm chart into an operator. So if all you care about in the operator is installation and installation and removal, no problem. You can write a Helm chart. But if you start to care about upgrades and secret management and clustering, then you need to start that you're ratcheting up the expertise required.
So why use an operator if you can just use a Helm chart?
Yeah, the reason would be we have a chart, a graphic on the SDK that explains this, but essentially Helm is really great for installation and removal and management. But then once we call that a phase one operator. Phase two is, well, how do I handle upgrades? How do I handle clustering? Phase three is, well, how do I handle scaling? What do I worry about for monitoring? And these, as you start to move up the sophistication, that requires custom logic. You can't just say, well, deploy it. You have to actually do ongoing health checking and maintenance of the system. And then that requires software engineering. So,
Diane, for you, I'm curious about how this story about the operator is surfacing in the community and the people who you're talking to, and because you do a lot of traveling and you're out on the road a lot talking with customers and users.
So I think it's been an evolution, because first we were trying to convince everybody to put things in containers and make them containerize them. So I think this is the next step of community education that we're going to be doing over the next coming months. Is what is an operator, how to create one, and what are the different use cases for them. And so from my perspective, I think that's really where the community is going to have to step up and start working and creating these new operators. I think we're going to have to do a lot of outreach and education, and it's a learning curve, I think. And that's where the community comes into play. In the Kubernetes community and the OpenShift community, that's our role, is to really help people get this stuff in action.
Go ahead.
I was going to say, though, because Aparna Sinha from Google in the keynote said that she felt like this was going to be the next biggest innovation after Kubernetes itself. So what is so innovative about it? Like what makes it so important?
I keep going back to the analogy of public cloud. I think the big innovative thing here is public clouds have these services, but the public cloud owns those services.
Yeah.
You can't take them anywhere else.
No.
You can't run them on your laptop, and you can't add your own. There's going to be tons of people out there who there's a big enterprise stack of software that they care about. It's a stateful stack of software, and it's just so prohibitively difficult for them to manage that, or even to create a testing and integration copy for engineers. But if they go through and they do the work to build an operator and they tie themselves to the Kubernetes API, now suddenly the engineer is able to deploy that complex stack really simply on their laptop, get it up onto the hybrid cloud, run it on public cloud, run it in their data center. And I think that's what's innovative. It's taking what made cloud so popular, democratizing it as part of the open source community, and then enabling any organization, because of that democratization, to start to deliver that to their engineers. And it's not just, it's essentially enabling the long tail of software. Like, cloud is servicizing or cloudizing the most popular, like 95th percentile most popular open source projects. There's a huge amount of value and huge number of systems that people rely upon every day that just simply will never have a public cloud equivalent. And so I think that's the big motivator and the big opportunity for Kubernetes, is to capture what's just not practical to build as cloud services and make them Kubernetes native services.
And it's really kind of delivering on the promise of automate everything.
Right.
This is, you couldn't automate, you weren't allowed to automate everything before, or you were limited to whatever they had already automated for you. So this is bringing it down out of the public cloud to anywhere. And that's the big change. And I think that's what the excitement is about this week.
One of the questions I have is about, I remember actually CoreOS Fest, when, was it last year, when you had it, and you guys were talking about state. You had there was a kind of like, we need to figure this out.
Yep.
Right. Was that the beginning of your kind of thinking about operators?
Yeah. So we started building things with operators that were stateless, and so that was probably the first 6 months, year or so, and then obviously we wanted to start to tackle things. State is where the money is at the end of the day. Like, people, their businesses, their livelihood depends on state, and so we need to get Kubernetes in a spot where it's able to handle these stateful applications, and to a large degree you're seeing a lot of innovation there. There's Red Hat has a whole storage subsystem that can run on top of Kubernetes now. You're seeing a lot of open source projects doing Kubernetes state management, and it's going to be a continuing discussion, because particularly in the public cloud, there's so much state that's being stored in these APIs, and again, we need to bring it back into Kubernetes, and it'll be an ongoing discussion and engineering challenge. There's no system more challenging than state.
Yeah, because I wonder about, Couchbase has a story that Libby pointed out to me about why they think operators are a game changer. I mean, talk about a company that deals with state. Okay, that is what they do. So why would they be? And why would they be so captivated? I mean, the article will tells it, but why are companies like this captivated by this? If there still is so much engineering to do to get it really, kind of in a place where it actually can be thought of and really applied to production.
I just go back to why is a company like Couchbase excited? It's because twofold. They're able to offer their services as an API call, which
right. And then they manage the state.
Right. And they manage the replication. And for the first time in open source, they're given APIs that allow them to say, or enable them to say, well, what copies of our database exist? How up to date are they in the replication cycle? And they have APIs to drive this. Where in the past, every single database vendor spent a lot of time being really creative and building these APIs for themselves. Whereas if they can lean against Kubernetes, that's huge. And it's quite simply, like, if you're a database vendor, you want developers using your database, and if it's an API call away, it's going to ramp usage of your database a ton.
Gosh, operator. I love it. I love it.
Hello, operator.
Hello. I think there's like a song.
Hello, operator. Yeah, there you go.
Hello, operator. Pancake.
Alex, so you raised an issue with that. Putting the database, the application in control, essentially, because. I mean, what was your concern with that?
Well,
because
I think there's a metering mechanism here that's interesting, right? It's like, APIs are great. We love APIs, but what if the provider says, no more API for you? I mean, it becomes a kind of a game. It becomes not, and it's not necessarily built into the operator, I don't think. It's built into the values of the provider who's building their own operator and what components they make available.
Right. So the next component of the operator framework, we have many components coming in the operator framework, is operator metering. And so what we're doing is actually not necessarily doing the license and compliance side of metering, but the chargeback side. But we're doing the accounting side. So how many instances exist? How much CPU, how much memory was consumed by those instances? And we'll be open sourcing that in the next few weeks too. And that's going to be really exciting because. Imagine a Couchbase. They want to know how many instances exist. Imagine an open source project like Cassandra. They'd probably love to know, at their conference, be able to say, we have hundreds of thousands of terabytes under management across hundreds of thousands of clusters. And I think that's another place where Kubernetes API-driven compute, network, and storage allows for people to build these systems that give them the data that they actually need to operate and have these higher level concerns be taken care of. So.
Well, thank you both. Congratulations again. It's great to see the both of you and have this conversation. This story of the operators is an ecosystem and a community story, and it's really going to be interesting to kind of observe and watch and see how this unfolds. I mean, I'm just reading about lots and lots of database companies alone that are wanting to use the operator. So I think this is significant. So congratulations.
Thank you.
Thank you very much.
Great. Thanks. Well, we'll be back soon.